2.2 Trigonometric functions of non-acute angles, reference angles, special angles as reference angles, determination of angle measures with special reference angles. So let's talk about reference angles. Um, a reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. So basically it's how far are you from the x-axis? That's what the reference angle is how far are you from the x-axis? See here? How far are you from the x-axis? Only the x-axis. Remember, we could hardly ever care about y, it's all about x. So a reference angle, theta, first must be in between 0 degrees and 360 degrees. So it has to be a coterminal angle if not. So if it's above 360, we have to find the coterminal angle. Okay, one of the biggest errors is that we find reference angles referring to the y-axis, but remember, it's only the x-axis. We could care less about y. So how do I remember that x is pretty much the ruler of everything? We always plug in x. So that's literally how I remember it. Usually it works. We only care about x. All right, let's find reference angles. So let's find the reference angle for an angle of 218 degrees. So 218 degrees, that is between 0 and 360. So we're good. So I'm going to draw it out. I'm going to show you what a degree of 218 degrees kind of looks like. So we have our coordinate plane, right? So 218 degrees, that's about right here. So that means it's opened up 218 degrees. So to find the reference angle, what we're finding is what is this right here? What is that degree between that ray and the x-axis? What's that degree? So we're trying to find the reference angle. Reference angle is theta apostrophe. So the reference angle for this one, it's going to be theta minus 180 degrees. Now, why is it minus 180 degrees? So, you see here how the angle went just past 180? So we want to know, how do I get back to this? This right here, this line right here is 180 degrees, this whole line. So it's how do I get back to 180 degrees, and that's why we subtract, because we're trying to get back to the 180 degree mark. So our original angle was 218 degrees, and we're going to subtract that by 180, and we get our reference angle of 38 degrees. That means this right here, that little part, is 38 degrees. Now you're going to figure out why that's so important coming up in this section, so just bear with me. Alrighty, part B. So finding our reference angle, we have an angle of 1,387 degrees. So that is not between 0 and 360. So we first need to find the coterminal angle. So do 1387 degrees minus 360, and we get 1027 degrees. I have to get it between 0 and 360, so subtract again. When we subtract again, we get 667. We got to subtract one more time, and we get 307 degrees. So what that looks like, 307 degrees. So that's the coterminal angle to 1387. So it's the same thing, remember? These two represent the same angle. So when we draw it out, it's about right here. So it goes around 3 times. So 1, 2, 3. There we go. There's our angle. Now what we're trying to find is the reference angle. So the reference angle is this right here. So this, I have to go up to that point, right? So this point here is 360 degrees. This right here if we go to that point, it's 360 degrees. Now I'm not going to add 360 because if I add 307 and 360, we get a really, really big number. So it's what's the makeup? What's the leftover? So we're going to subtract by 360. And we get 53 degrees. That means this right here is 53 degrees. Now, the reason why we didn't add 360, because if we added 360, you see how we get an angle that's over 300? It's over 360, it's 667 degrees. That's not a reference angle. A reference angle is always between 0 and 90 degrees. So let's actually write that. A reference angle, that's a horrible theta. A reference angle is between 0 and 90 degrees. So that's how I knew not to add. Now these are the rules. These are the rules that how do we remember to add, subtract, 180, 360. Here are all the rules, and I'm going to break them down. Alright, so when you have an angle between 0 and 360, we can go ahead and find our reference angle. So if it's in quadrant 2, we subtract to 180. We subtract to it because we need to get down to the 180. So that's why we subtract to it. So 180 minus theta. In quadrant 1, your reference angle is your theta because that is between 0 and 90 degrees. Since that's the case, your theta is your reference angle. In quadrant 3, we do theta minus 180 because we need to know how do we get back to 180. Quadrant 4, it's the only one with 360, so we subtract theta to 360, and that's how we get our reference angle. So how do I remember between quadrant 2 and 3? Because 1 and 4, easy to remember, they're very different. But 2 and 3 they're so close it hurts, right? So the quadrant 2, we go down to 180. So that's why we subtract. Here, we go up to 180. So that's why we do theta minus 180. So here, we're going down. So it's 180 minus theta. Here, we're going up. So we could even do 180 negative 180 plus theta, but we don't like to see it that way. So if we need to go back up, we're taking how much theta has gone over the 180 degrees. Because we're saying so this is our theta. So in the example we just did, it was 218 degrees. Then how much did I go over? That's why we subtract to 180, because we're figuring out what's the difference. How much did you go over that one? And here, it's how much left do you have to make up? How much more do you have to go to get to 180? All right, let's figure out why finding reference angles matters so much. So we're finding trig function values of a quadrant 3 angle. So find the values of the 6 trigonometric functions for 210 degrees. So it tells us quadrant 3, but we know 210 is in quadrant 3. So first thing I'm going to do is draw quadrant 3. Now I'm going to draw our angle of 210 degrees, so that's about right there. So now what we're trying to find is this right here, that angle right there. So since we're over 180, we need to know how much left, how much did we go over 180. So our reference angle is our theta, so 210 minus 180. And we get our reference angle is 30 degrees. So that means this is 30 degrees. So if we finish off our triangle, this is 90 degrees because it's perpendicular to the x-axis. So that means we have a 30, a 90. By default, this is 60. We have a 30, 60, 90 triangle. I know that is 60 because I have one that's 30 and one that's 90, so the rest to make up a triangle, which is 180 degrees, is 60. So because we have a 30, 60, 90 triangle, Now, let's keep in mind, let's figure out, okay, I did all that, but what is it actually asking me to do again? We're trying to find the 6 trig functions, meaning sine, cosine, tangent, cosecant, secant, cotangent. That's what we're trying to find. So when we're trying to find all the 6 trig functions, we need these lengths right here. So we need x, we need y, and we need r. This goes back to 2.1. Look at 2.1 notes. We have a 30, 60, 90 on there. You have to remember what a 30, 60, 90 is. But it's easy to remember. A 30, 60, 90 is always 1, 2, square root of 3. Your square root of 3 could be positive or negative, and your your y can be positive or negative. So your x is always the square root. So it's either positive or negative 3. And since we're on the left side right here, that's negative x's, so that's negative square root of 3. So our x is negative square root of 3. It's either going to be positive square root of 3 or negative square root of 3. If it was the other side, if it was right here, it would be positive square root of 3. So then our y is always going to be positive or negative 1. Since our y is going down, this right here, since it's going down, it's going to be negative 1. And then our r, which is the hypotenuse, it's always positive because it's a distance, so it's just your 2. So now we have all of our legs and our hypotenuse. So now we can find sine, cosine, cosecant, secant, cotangent. So let's find sine 210 degrees, because that's what we're trying to find, the 6 trig functions for 210. And we do all of that by using our reference angle, because it gives us a 30, 60, 90 triangle. So sine is opposite over hypotenuse, so negative 1 over 2, which is just negative 1/2. Then the reciprocal of that, which is cosecant. So cosecant 210 degrees, we just flip it. So negative 1/2, when we flip it, it's just negative 2. Now we have cosine 210 degrees. So cosine is adjacent over hypotenuse, so negative square root of 3 over 2. That's rationalized, so we're good to go. Now, the reciprocal of cosine, we have secant 210 degrees, so we flip it. That means we have 2, sorry, this negative should be in the middle. So when we flip it, we have 2 over square root of 3, so we rationalize our denominator. We'll have negative 2 square root of 3 over 3. Now we have tangent. So tangent 210. That's opposite over adjacent, so negative 1 over negative square root of 3. So we rationalize our denominator. We have square root of 3 over 3. The negatives cancel. And then for our reciprocal, which is cotangent, so cotangent 210 degrees, we have just flip tangent, so 1 over square root of 3, when you flip it, it's just square root of 3. That's why it's important to know what a 30, 60, 90 triangle is. Also a 45, 45, 90 triangle. Because then it gives us the values we need. Alright, finding trig function values for any non-quadrantal angle, theta. So the first thing we need to do is, if it's above 360 or less than 0, we need to find the coterminal angle. To get it in between 0 and 360, we're going to find the reference angle, find the trig function values for the reference angle, and then determine the correct signs found in step 3. So is it supposed to be positive? Is it supposed to be negative? Example 3, finding trig function values using reference angles. So we need to find the exact value of cosine negative 240. Alright, so negative 240, that's coterminal, because that's not between 0 and 360. So let's go ahead and find the coterminal angle. So we do negative 240 plus 360 and we get 120 degrees. So that means that's the coterminal angle. So now that we have that, we can go ahead and find the reference angle. So the reference angle, we either need, so since we're in quadrant 2 here, 120 degrees, that's quadrant 2, we haven't passed 180 yet. So we need to know how much do we need to get there. So we do 180 minus 120, and we get our reference angle of 60 degrees. So we first started with cosine negative 240. Then we switched it, because we know coterminal angles, we switched it to cosine 120 degrees. Now we found the reference angle. The reference angle of cosine 60. So using that little chart from 2.1, that yellow chart, I'll show you. So it's not yellow, sorry. That colorful chart, cosine 60 is 1/2. But we're in quadrant 2, aren't we? We're working in quadrant 2, so we have to remember, is it going to be positive? Is it going to be negative? In quadrant 2, remember cast? If I drew the little cast real quick, C-A-S-T. In quadrant 2, cosine is negative. So we have to make sure it's negative, because in quadrant 2, it's negative. That's what step 4 is, determine the correct signs of the values. That's figuring out, using cast, is it positive or is it negative? Because we're in quadrant 2, it's negative. Alright, B, find the exact value of tangent 675. So, obviously that's coterminal, so we need to find our coterminal angle. So we do 675 minus 360, and we get 315. Sweet. So we turned tangent 675, we found out that it's the same thing as tangent 315. So now we can go ahead and find the reference angle. So our reference angle, since we're working with 315, that's quadrant 4. So quadrant 4, that's the one with 360. So we have 360 minus 315. And we get 45 degrees. Looky there, we have a 45-45 triangle. Now, you could use that little chart that I just showed you. We could, if we use that little chart, we could say that since we're talking about coterminal angles, we have negative tangent 45 degrees. We could use that little chart, and that little chart states that it's +1. But since we're working in quadrant 4, tangent is not positive, so it would be -1. Or we could use triangles. So if we drew quadrant 4, we know we're in quadrant 4 because of our coterminal angle of 315 degrees. So if we drew our original angle is somewhere about here. It goes around twice. So once, twice. That's 675 degrees, sorry. Then we found out that's just the same thing as 315 degrees. That led us to saying, well, I can find the reference angle now. So the reference angle is 45 degrees. So we finish out our triangle. That means we're working with a 45, 45, 90 triangle. So 45, 45, 90, it's 1, 1, 2. It's just whether it's positive or -1. So it's always 1, 1, 2. Your x is 1, positive or -1. Your y is positive and -1. And your radius or hypotenuse is square root of 2. So since this is on the positive x side, it's +1. This is going down, so it's -1. And then our radius is square root of 2. So using that, we could do tangent 675, which is opposite over adjacent. So opposite is -1. Adjacent is +1. So that's how we get the -1. So there's a couple ways that you can think of each of these. You necessarily don't have to draw a triangle. You can use that chart. But to me, drawing a triangle, it just makes all that much more sense. All right, example 4, using function values of special angles. So we want to evaluate cosine 120 plus 2 sine squared 60 minus tangent squared 30 degrees. That's supposed to say degrees. It's just a typo. We know cosine 120, that's -1/2. For multiple reasons, that's why we know. We figured it out ourselves, right here. So we already did it. Pay attention to what you've already been doing in your homework, because sometimes answers you already have work out for other questions. Also, you could have just used your triangles or that little chart, but that's okay. We already know cosine 120. All right, so next we have 2 sine squared 60. So let's go ahead and find sine 60 degrees. Now you could use that nifty little chart. You could see that sine 60 is square root of 3 over 2. But let's say you're not using that chart, but you do know what cosine 120 is. So what we could do is use the Pythagorean identity. So if you wanted to find it without using that nifty little chart, because you're not good at remembering charts, I'm not good at remembering charts. What we could do is find out what it is because we're given cosine. So we could use sine squared theta plus cosine squared theta equals 1. So we have sine squared theta plus cosine squared, which is -1/2, equals 1. So we have sine squared theta plus 1 over 4 equals 1. Subtract 1 over 4. We have sine squared theta equals 3 over 4. Take the square root. So we have sine theta equals square root of 3 over 2. Now, is it positive? Is it negative? How do we know which one? Well, 60 degrees is in quadrant 1. So everything is positive in quadrant 1, so this is positive square root of 3 over 2. Two very different ways to find the same answer. It's just how do you remember things? Do you want to remember that chart, or are you just better at remembering formulas? It's all up to you and how you work. Alright, so we found cosine, we found sine, now we need to find tangent 30. So remember, tangent is cosine over sine. We have cosine, and we have sine, so let's plug it in. So we can find tangent 30 by doing cosine over sine. So -1/2 divided by sine, which is positive square root of 3 over 2. Our denominators cancel. So we're left with -1 over square root of 3. And that's the same thing as negative square root of 3 over 3. So now we have all of those values. What we're going to do is plug them in to what we have. So what we do is we evaluate each little function and then plug it back in. So we have cosine 120, which is -1/2, plus 2 sine squared 60. So we have 2 sine. We found just sine. We found single sine. Single sine was square root of 3 over 2, but we still need to square that. Minus tangent squared 30. We just found normal tangent. So normal tangent is negative square root of 3 over 3. And we still need to square that. So what I did is just plugged in the values themselves, not the square, because we didn't square anything yet. We just found the values. Now we're going to square it. So we have -1/2 plus, so we square this, we have 2 times 3 over 4, minus, we square this, 3 over 9. So we keep simplifying. We have -1/2 plus 6 over 4 minus 3 over 9. You could have used your calculator at this point. We get 2 over 3. So cosine 120 degrees plus 2 sine squared 60 degrees minus tangent squared 30 degrees is 2/3. Using coterminal angles to find function values. Evaluate cosine 780 by first expressing the function in terms of its angle between 0 and 360 degrees. We'll do the rest after. Alright, so part A. So part A, it wants us first to find the coterminal angle because it's between 0 and 360 degrees. So we do 780 minus 360, and we get 420. We need to subtract again, and we get 60 degrees. So if we're trying to find cosine 780, which is cosine 60 degrees, remember that is its reference angle. So since it's 60 degrees, we're going to be using a 30, 60, 90 triangle, or cosine 60 we know is 1/2. It's positive because we're working in quadrant 1, because your theta is your reference angle and it's all in quadrant 1. Alrighty, part B. Evaluate cotangent negative 405 degrees by first expressing the function in terms of its angle between 0 and 360 degrees. So it's negative, that means we need to find the coterminal angle. So negative 405 degrees plus 360 degrees, and we get negative 45. So add it one more time, and we get 315 degrees. So we're working in quadrant 4. So now we have cotangent negative 405, that turned into cotangent 315 degrees. Now we need to find the reference angle. We're in quadrant 4 because 315 degrees is quadrant 4. So we do 360 minus 315, and we get 45 degrees. So now we have negative cotangent 45 degrees. All that means is reference angle. So we're going to use a 45, 45, 90 triangle. So 45, 45, 90 triangle. That's a little harder one to remember for me. I don't know why it's hard for me to remember those numbers. So we're working with a 45, 45, 90 triangle. So we can draw it out, or you could just use that little chart. It says cotangent is 1. But since we're working in quadrant 4, where's my cast at? I knew I drew it. Quadrant 4, it's not positive. Tangent and cotangent is not positive, so that's why it's negative 1. If we used our triangles, what we could do is just draw our triangle. So we're in quadrant 4. We have our angle, our coterminal angle of 315 degrees, and then we have our reference angle of 45 degrees. So we finish off our triangle. Remember, it's always 1, 1, and 2. Your hypotenuse is always 2. So since this is to the right, it's positive 1, and since this is going down, it's negative 1. So cotangent is the opposite of tangent, so it's adjacent over opposite. So it would be adjacent, which is 1. Opposite, it's negative 1, which is just negative 1. So you could have used your triangles as well. It doesn't matter. So you could use the chart, or you could use the triangles. Alright, part C. Find all values of theta if theta is in the interval of 0 to 360 degrees and cosine theta is negative square root of 2 over 2. Cosine is negative. It equals a negative number. It tells us right there. Since it's negative, cosine, if I drew cast, cosine is negative in quadrant 2 and quadrant 3. That's where it's negative. Alright, so we're getting somewhere, right? We get our quadrants. So we know square root of 2 over 2, whether it be positive, negative, it doesn't matter. Square root of 2 over 2 only comes from a 45, 45, 90 triangle. How do I know that? Because 30, 60, 90 has the square root of 3 in there. Remember, 30, 60, 90 is 1, 2, square root of 3. 3 goes with 30, 3 with 3. 45, 45, 90, it's 1, 1 square root of 2. So that's how we can get square root of 2 over 2. So we know it comes from a 45, 45, 90 triangle. Now I can go ahead and draw quadrant 2 and quadrant 3. So let's draw quadrant 2. So quadrant 2, we have our angle of, we don't know yet, so we need to find it. So somewhere an angle is in quadrant 2, there's the angle. I don't care where it is, that's where it is. Sweet. Okay, we're going to finish this off. We know it's a 45, 45, 90. So 45, 45, 90. So we have some type of angle in quadrant 2. Awesome. Let's fill it out. So we have square root of 2, 1, negative 1. It's negative 1 because it's on the left side of the x's. So what we're trying to find is the angle that this creates. What we're trying to find is this right here. So we can find that because we have the reference angle. We know that the reference angle is 45 degrees because we're working with a 45, 45, 90 triangle. So that means, how did we get that reference angle? So if we were given theta, wouldn't we do the theta minus 180 to figure out how much is left? So what we need to do is just do the opposite. So what we're going to do is take 180 and add it to our reference angle, and we get 135 degrees. How do I remember to do that? Because it's a little weird. So here, that's the reference angle, and that gives me how much is left over to 180. What I'm trying to find is the whole thing. This whole thing, sorry. Alright, now we draw quadrant 3. Why do we draw quadrant 3? Because where this results, it's in quadrant 2 and quadrant 3. That's why it says find all angles. So quadrant 3, so we have an angle somewhere in quadrant 3. Okay, awesome. That's our angle. We finish off the triangle, and since this is a 45, 45, we know that this is negative 1, and square root of 2. So we have a 45, 45, 90 triangle. So our reference angle is 45 degrees. So what we need to do is just the opposite of what we would normally do. So if we went back to this right here, wouldn't we subtract, let me get a different color, wouldn't we subtract to get to this reference angle? So what's the opposite of subtracting? Adding. So what we're going to do is we're going to take our reference angle, and add it to 180. So we have 180 plus 45, and we get 225 degrees, which makes sense because that is in quadrant 3.